Chapter 11 is about the mechanics of capital budgeting, the metrics we use to evaluate potential investment projects. In the full chapter, we'll cover 5 methodologies: net present value, internal rate of return, modified internal rate of return, payback, and discounted payback. While one method, NPV, dominates, all 5 provide information about the viability of potential investments. In this first part, we focus on the 2 primary metrics used, NPV and IRR. Capital budgeting is one of the primary functions of the finance function in a corporation, and a very important one. Capital budgeting can involve a new product, a new piece of machinery, a new facility, or an acquisition. The decision to take or reject can determine the long-term strategic direction of the firm. Besides the strategic importance, capital budgeting projects typically involve large sums of money and would be difficult or impossible to reverse. Here are the 5 steps involved in capital budgeting analysis. Estimate the cash flows and assess their riskiness, Chapter 12. Determine the appropriate weighted average cost of capital. We just did that, Chapter 10. Find NPV and IRR and decide accept or reject. That's this chapter, Chapter 11. An independent project is one whose cash flows do not affect any other project. If 2 or more projects are mutually exclusive, taking one automatically precludes taking the other. For example, the decision as to whether to build a plant on a plot of land or sell the land are mutually exclusive. You can do one or the other. If projects under analysis are independent, a firm can choose all, none, or any set. Why is this important? If a group of projects are independent, then we only need to decide go, no-go on each one. If the group is mutually exclusive, then we must be able to select the best project, the second best. We must be able to rank them. And as we'll see, not all evaluation methods are capable of ranking. A project with normal cash flows has one outflow, investment, followed by a series of positive inflows for the life of the project. One change in sign from T0 to T1. Non-normal cash flow stream has 2 or more changes in sign. The example given is a strip mine, when the land must be reclaimed when the mine is exhausted, causing a large negative cash flow at the end of the project. Net present value is the dominant capital budgeting evaluation metric. Technically, for a normal cash flow project, it's just the sum of the discounted inflows netted against the time zero investment. More generally, this is the main use of the cash flow worksheet in the TI Business Analyst 2. This is what it's made to do. Here are 2 sample projects we'll use to demonstrate the various methods. Project L is a long-term project in the sense that its cash flows start small and build. Project S is the opposite. Its cash flows start with a bang in year 1 and decline. The column change in cash flows, we'll be using that later. Looking at Project L, here is the calculation of its net present value. Discount each cash flow and add them up. Since cash flow 0 isn't discounted, the value remains the same. Each successive cash flow is discounted by dividing by 1 plus the cost of capital raised to a power equal to the period. So the year 2 cash flow of $60 is divided by 1.10 squared. Note the Excel function at the bottom. Excel has an NPV function with a slight peculiarity. Cash flow 0 cannot be included in the range inside the function. It has to be handled outside. Apparently, NPV was designed this way originally in Excel, and you sure can't change it now. This shows Project L's cash flows placed on a timeline and discounted. Project L's NPV, $18.79. Looking now at Project S, we find an NPV of $19.98. Since this calculation is perfect for the TI Business Analyst 2 cash flow worksheet, we'll work through one. I suggest you get your calculator and follow along. As mentioned in the TVM chapter, familiar with the cash flow worksheet operation is important. So in your calculator, press CF, second, clear work. With cash flow 0 displayed, enter 100 plus or minus, press enter and the down arrow. Remember the pattern from the TVM lesson in the videos. With CO1 displayed, enter 10, press enter and down. With FO1 equal to 1 displayed, just press enter and down to accept a frequency of 1. Repeat for all 4 cash flows. When all cash flows are entered, press NPV. With I equals 0 displayed, enter 10, enter, down. With NPV equals 0 displayed, press Compute. Try it out. Be sure you get the correct answer, 1878. If the present value of the project's inflows exceeds the initial investment, then the project should be accepted. If the projects are independent, then all projects with NPVs greater than 0 should be accepted. If the projects are mutually exclusive, NPV can be used to rank, the project with the largest NPV being the most desirable. In our example, the NPV of the long project, 1878, the short one, 1998. So the short project is the better project, but both are acceptable. NPV meets all the desired criteria for a capital budgeting method. All cash flows are considered in the computation. We use all the data we have. TVM is considered. Basic finance. NPV can be used to rank mutually exclusive projects. NPV is directly related to the value of the firm. In theory, if a project is accepted and pursued, the value of the firm will increase by the amount of the NPV. NPV is the dominant method. It always prevails. If other techniques give conflicting accept-reject decisions, NPV is the final word. Closely related to NPV is the internal rate of return, or IRR. IRR is the discount rate that makes NPV 0. While it's possible to solve for IRR manually, it's iterative, meaning you try values until you hit the answer, because there's no closed-form solution. Much easier to use your financial calculator or Excel. In the TI Business Analyst 2, enter the cash flows as you did to solve for NPV. Or if you just solve for NPV, the values are still in the CF worksheet. Instead of pressing NPV, press IRR and compute. In Excel, the IRR function allows you to enter a guess, but it's not required, and the function expects the entire cash flow range, CF0 to CFN. Looking at the NPV and IRR formulas together. With NPV, we solve for a dollar amount. With IRR, we're solving for the root of a polynomial of degree n. For our project L, the cash flow should still be in your CF worksheet from the NPV calculation, so just press IRR and compute. After a very slight hesitation, the IRR is displayed. The IRR for project L is 1813. For project S, 2356. The decision criteria for IRR is simple. If a project's internal rate of return is greater than the firm's cost of capital, accept the project. If less, reject it. Note that if projects are independent, we would accept both projects. Both IRRs are greater than the cost of capital, 10%. If they're mutually exclusive, they should not be ranked on IRR. Why? Let's say project X has an IRR of 15%, but an NPV of $1,000. Project Y has an IRR of 10%, but an NPV of $1.5 million, which would be a better choice. Why? NPV dominates. More money is better. IRR has several strengths, not the least of which is that it's preferred by executives who seem to like a percentage return. It does consider all the cash flows, and it does consider time value of money, and it does provide some indication of risk. Consider, if the IRR of a project is 15% and the firm's cost of capital is 10%, there's a lot of leeway to make errors in cash flow estimation and still have a profitable project. If the firm's cost of capital is 14%, not much room for error. IRR does, however, have some serious flaws. You cannot use it to rank mutually exclusive projects. Two issues that we'll explore in more depth are the problem of multiple answers and the reinvestment assumption. Before you go further, take the time to view this video tutorial. It walks through finding NPV and IRR in the TI Business Analyst 2 Plus using the cash flow worksheet with a calculator simulator on the screen so you can follow the steps. This ends our coverage of the first two capital budgeting methodologies. In Chapter 11, Part B, we'll cover modified internal rate of return, payback, and discounted payback.